exciting new study shows that we have significantly underestimated the size of Betelgeuse and its evolution timeline. According to the latest observations, researchers say that Betelgeuse will seem to explode in a few tens of years rather than hundreds of thousands of years. This is a big deal because Betelgeuse is located about 650 light-years away from us, which means that what we will see now is actually how the star appeared 650 years ago. If the study is correct, it means that Betelgeuse has already gone supernova, and we might be fortunate enough to witness this incredible event in our lifetime. But how did scientists come to this conclusion? What evidence do they have to back up their idea? Finally, and most importantly, what would happen if the light from Betelgeuse's supernova reaches us while we're still around? Betelgeuse is a red supergiant star sitting on the shoulder of Orion. It's about 200 parsecs, or 650 light-years away from us. Astronomers concluded that we were wrong about the size and evolution timeline of Betelgeuse by studying its fundamental and overtone modes of pulsations. Let me explain it in a simple way. Stars are not just static points of light in the sky. Many of them are actually pulsating, meaning they are constantly expanding and contracting. This is a lot like how your heart beats, expanding to fill with blood, then contracting to push that blood out into the rest of your body. The rhythm of a star's pulsation is driven by a sort of stellar heartbeat, which is set by waves that travel through the star. This pulsation occurs because of the ongoing battle between gravity trying to crush the star and the resistance from nuclear fusion energy and gas pressure. The fundamental mode of these pulsations is the simplest way the star can pulsate. It's like the basic heartbeat of the star, where the entire star expands and contracts together. Imagine jumping straight up and down in the center of a trampoline. The entire trampoline surface goes down and comes back up in unison. This is analogous to the fundamental mode of a star's pulsation, where the entire star is expanding and contracting together. On the other hand, overtones, also known as harmonics, are more complex modes of pulsation. They involve different parts of the star expanding and contracting at different times. Instead of the whole star expanding and shrinking uniformly, like in the fundamental mode, the star might have areas that are expanding while others are contracting. It's like when two people are on a trampoline, each bouncing in different spots. The surface of the trampoline won't just be moving up and down uniformly. Instead, there will be complex patterns of waves moving around, with different points on the trampolines going up or down independently. This is similar to the overtones in a star's pulsation, where different parts of the star can be expanding or contracting independently of each other. By studying the periods of these pulsations, astronomers can model the conditions inside the star that lead to these pulsations. It's like understanding what's happening at the core of the star by observing its behavior on the outside. Over the centuries, astronomers have observed Betelgeuse and noticed its semi-regular variations with approximately 4 periods: 2200 days, 420 days, 230 days, and 185 days. Initially, they believed that the 420-day pulsation cycle was the fundamental mode, and the shorter cycles were overtones. The 220-day cycle was considered a long secondary pulse of unknown origin. Considering the 420-day cycle as the fundamental one, Betelgeuse would span 800 to 900 suns lined up. That's big enough to reach the edge of Jupiter. However, in their research paper, Seo and colleagues have presented evidence that the 2200-day cycle is actually the fundamental mode, while the other 3 are its overtones. This discovery indicates that Betelgeuse is much larger than we previously thought, spanning over 1,200 times the size of our Sun. way beyond Jupiter's orbit. This revelation changes everything we knew about the star and what's happening on the inside. According to the new research, Betelgeuse has almost depleted all its carbon and is on the verge of undergoing a supernova. A star spends 90% of its life converting hydrogen into helium in its core. This phase of a star's life is known as the main sequence phase. A star the size of Betelgeuse spends around 10 to 12 million years on this phase, fiercely burning its nuclear fuel in the core at a temperature of around 15 million Kelvin. As the star exhausts its hydrogen supply, it enters the red giant phase. The core contracts under gravity, heating up, while the outer layers expand and cool, giving the star its reddish color. Once the core temperature reaches around 100 million Kelvin, it starts burning helium to form heavier elements like carbon and oxygen. Over time, the core becomes an onion-like structure of various elements, with the heaviest ones at the center and lighter ones in the shell surrounding it. Once the core temperature becomes high enough, carbon and oxygen start fusing into heavier elements, up to iron. This is where the tale takes a dramatic turn. Iron does not release energy when fused. Instead, it absorbs energy, making the core unstable. The star's demise is imminent. A star the size of Betelgeuse would take roughly 1,000 years to fuse carbon into heavier elements in its core. Exactly finding out how much carbon is left in the core of the star at this stage is challenging. However, when scientists studied the pulsations and brightness of Betelgeuse, they found that it only has between 0.48% to 17% of carbon left in its core. This means that Betelgeuse has already used up a significant portion of its carbon and only has a few decades left before it explodes into a supernova from our perspective. In real time, the explosion may have already occurred. Since the beginning of the year, Betelgeuse's brightness has surged by over 50% above its typical luminosity. After the great dimming of 2020, the supergiant star has lost its 420-day pulsation cycle, a feature that has been exhibited by the star at least for the past few centuries. This further indicates that something weird has been happening on the star. The last time we had the chance to see a supernova with our naked eyes in our own galaxy was way back in 1604. It was called Kepler's supernova. But now, with the revised timeline for Betelgeuse's explosion, there's a glimmer of hope. We might just be fortunate enough to witness this extraordinary cosmic spectacle in our very own lifetime. It's a truly exciting prospect. The reason why everyone's excited about the supernova of Betelgeuse is that it will be an event of epic proportions. When Betelgeuse finally explodes in our frame of reference, its brightness will surge dramatically, potentially surpassing the moon and becoming visible even during daylight. This intense luminosity, however, will not last forever. After a few weeks of radiant spectacle, the light will gradually diminish. Yet it could remain observable to the naked eye for an extended period, perhaps over a year. Despite the immense energy unleashed during a supernova, the significant distance between Betelgeuse and Earth ensures that our planet will not suffer any adverse side effects from the explosion. The vast expanse will dilute the impact of the supernova, shielding us from harmful radiation. Supernovae like this one are rare and precious events within our galaxy. They give us valuable information that helps scientists understand how stars live and die, the complicated physics behind supernovae, and how elements are spread throughout the universe. Supernovae are like cosmic factories that create heavy elements such as gold and platinum. So getting to witness this process up close is an incredible opportunity for researchers. After the supernova, when the dazzling show is over, Betelgeuse's core will still exist, but it will have changed. It might become a neutron star or maybe even a black hole. Seeing the remains of Betelgeuse from our distant spot on Earth might be difficult. But with advancements in technology, it's not impossible. Recently, astronomers spotted the largest explosion in the universe so far. It's so energetic that no physics phenomenon has been able to explain it so far. If you missed this episode, be sure to catch up on this exciting discovery.